Assalamualaikum and good day everyone. In this video, we are going to deep dive into Java collection by analyzing two practical coding examples that utilizes array list and linked list. My name is Khalila Izzati binti RD and this is a part of my CSC508 assignment. First, we will look at a rainfall tracker that utilizes an array list to collect and analyze annual weather data. Then we will look at a customer management system that leverages a linked list to efficiently manipulate a list of client records. Let's start with our first application. Before managing a list, we need a blueprint for our data. Here is the rainfall class. It can select two crucial attributes, a string for the month name and a double representing the amount of rain. And then we have a default constructor initializing these values to empty or 0 and a parameterized constructor, which is the normal constructor, to assign custom data when we instantiate the object. Finally, we provide a getter methods, which is getM and getR, to safely access these private fields from outside of the class. Now, let's move over to Rainfall app. Inside the main method, we initialize an array list called the list. An array list is a dynamically resizing array, perfect for when we want fast index-based access to our element. Then, by using a for loop that runs 12 times, once for each month, the application prompts the user with graphical input dialogues using J option pin. It takes the month and the rainfall amount. And then, it converts the input string into a double. Finally, it wraps it nicely inside a new rainfall object via the normal constructor earlier and adds it to our list using the list add R. Then we will initialize the total rain, the max rain, and the minimum rain. We also will initialize the index for when we are trying to search for the max and the mean rain. Once the data is populated, the second loop iterates through the collection. It tracks the cumulative total rainfall, while simultaneously identifying the indices of the months with the highest and the lowest value of rain. This can be managed by using this if-else statement here. By comparing the value of rain in each indices, the system will take notes which value is higher than the max value or lower than the minimum value. It will store the value inside the new min max and store its indices inside the index max and index min. And then we will initialize R max and R min so that we can get our R maximum rainfall and minimum rainfall values. Finally, we will prompt the system to print out all the information that we have gathered. We'll prompt out the total rain, the average rain value that we will be calculated by using the total divided by 12, which is 12 per month. And then we will print out the maximum value of the rain and the minimum value of the rain by using the getter method rmax.getM and rmin.getM. Let's look how the output will look like as soon as the user prompts all 12 values in the system. As you can see here, it will print out all the values that we mentioned earlier. Now, let's pivot to our second problem, which deals with customer records. The customer class will contain basic info of the customers, which is name, IC identity number, addresses, and phone number. We will also build the two constructors, the default and the normal constructor in this class. The default constructor, as I said earlier, we initialize this value to empty and 0. While the default constructor can give user an access to assign custom data when we instantiate the object. And then we will provide a get methods for all 4 variables. We will also be using a toString method. This is incredibly helpful feature in Java. Instead of printing in a cryptic memory addresses, overriding the toString method allows us to print nicely formatted customer summaries automatically when the object is pushed to the system console. Now, let's look at the ClassApp class. Here, instead of an array list, we are using a linked list. Linked lists are made of nodes bound to each other sequentially. They are highly efficient when you need constant time insertions or deletions at both the beginning and the end of the collection. We will also provide a scanner method so that the user can input to the system. Watch how the data is handled here. First, we will add Diana to the front of the list using add_first. Then, we will add Salsabila to the front of the list using the same method. Because Salsabila was added last to the front, she pushes Diana to the second spot. Next, we will append Farisha to the back of the list using add_last. After Farisha, we will append Fasiha next to the back using the same method. By printing via ClassList, the user can see all the customer information that is in the list. Next, the code demonstrates data removal. It calls ClassList.remove first, which drops Salsabila from the front, and ClassList remove last, which drops Fasiha from the back. When we print the list again, only 2 records remains, which is Diana and Farisha. Finally, to find a customer info based on phone number, firstly we will initialize a search phone value to 0. The program will prompt the user via the terminal to input a phone number to search for a customer. By using the for loop, we can loop through all the lists of the customers, and by using the if statement, we can use the get method to get the phone number from the customer list. We will match the phone number with the search phone value, and if the matches, the system will print out customer found. Finally, it will display the total count of the customer by using the ClassList.size method. Running the code, we can see that firstly it has total of 4 customers, and then there's 2 until remove and last, and we search for the phone number, the customer is found, and the total is 2. I hope this code breakdowns gives you a clear vision of how collections operate in Java. Thanks for watching and happy coding!